This is the Earth Science Classroom. Welcome back to the channel. So this is a lecture and lab activity I do with my students in class, and we're outside in the neighboring landscape, and there's this cool, nice hill, grassy hill just next to the classroom, and we kind of walk up to this pathway, this sidewalk, and kind of discuss the gradient of the landscape, the hilly nature of the surface, and explain how we're going to walk up this hill to figure out the gradient and to do this active lab activity outside and to take what's in the textbook and apply it to real life applications outside in the landscape. So you've got to start to walk up the hill. You take the elevation on the sidewalk, and then you walk up the hill, counting your steps, hopefully going heel to toe, so you get some sort of like accurate distance as you walk up this hill. It's kind of steep at some parts. You get to the top of the hill, and it's a nice view up there. Obviously, turn in the fall and autumn with the colors of the trees in the background. You get to the top of the hill and you take your elevation again. So you have an elevation from the bottom and the top, and you have your distance and steps, which would be your horizontal distance up the hill. And then you get to the top, and again, just appreciate the change in elevation, the landscape, and obviously from this point of view, we can see different degrees of slopes and where there's a valley and hill. As you can see, looking over to the across the parking lot, you see where you started from on the sidewalk, and then you end up at the top of the hill, and you can get your data. So the data you're collecting is the elevations from the bottom to the top and your distance of how far you walked from the sidewalk up to the top of the hill. So we come back into the classroom after doing the outside activity to gather our data, our dependent variable, which is basically going to gather how steep the hill is outside of our classroom. So from the video you saw that the hill is a certain distance, a certain elevation change, and you're measuring the elevation from the starting point, which is down by A, up to the top of the hill, which is B. So we're trying to figure out the gradient of this hill, which is basically a triangle. So if we take our triangle here and just extend this down, we're trying to find, the gradient, which is the measure of the steepness, the mathematical measurement. So this right-angled triangle, we can use Pythagoras to figure out our gradient, the steepness. So how steep is this hill in our outside area that we explored earlier? So our Pythagoras' theorem, the right-angled triangle, so we have A, we have B, and we have C. C is the hypotenuse. So our regular one is A squared plus B squared equals C squared. But we have, so in terms of gradients, the general formula is rise over run. Now rise, that is the change, the elevation change. So elevation change. And the run is basically the horizontal distance. Now be careful, because when you go and walk over a landscape, you're not always walking over the exact run measurement. You're doing something different. So as we walked up the hill, we actually walked up the C side of the triangle. Now what we want to do is, this B right here, that is our run that goes into our formula, like so. So we have the elevation change, which is the rise, which is A. So rise is A. We want to find B. We have C. So let's just say that we put in some numbers. Now this formula does not apply because that finds C. What we want to do is find B equals the square root of C squared minus A squared. So that's to find B. That's our run. That's our objective to put into this general formula for gradient. So to find B, let's just say that we did 100 steps, 100 feet for C, and the rise was, let's say, 10. Make it easy, nice easy numbers. So let's put this into our formula. B equals the square root of 100 squared minus 10 squared. So B equals the square root of 1,000 minus 100, okay? Because don't forget that when you square a number, it's timesing it by itself. So 10 times 10, 100 times 100. So this would be B equals the square root of 9,900. And you do that, and B is going to equal up, that will be 99.5. So put it into our triangle. This is 99.5, which is B. Put that into our lovely gradient. So rise was 10 over 99.5. So the gradient is going to be a decimal, and that would be rounded up to 0.1 as a decimal. So this equals, that would be a 10% gradient. Meaning that as you go horizontally or a distance of 1, you would increase your elevation by 0.1. So it's in this case, it is not a very steep slope, it's a very gentle slope. It slowly rises in this example. But when you put in your data from the outside lab, where you're actually walking the hill and you're walking the steps, and you are finding the difference in elevation from point A to point B, you can get a more accurate gradient for your hill. But this 10 and 100 are used for A and C, what we acquired. That was a generic, basic number to use, so you can see the nice progression of how to acquire B in your triangle here, which you can use for your gradient formula, rise over run. Once you have decimal, you can translate to a percentage, how the level of steepness in percentage, which you'll see on roads and signs, and your 0.1 decimal shows you how much you are increasing in elevation for every 1 unit going forward in distance.